Today we're going to be modeling with functions and learning how to write in function notation. Okay. Our exploring one, identifying an independent and dependent variables. The input of a function is the independent variable. Up to this point we have said that the input is our x values. So when we're talking about the independent variable, we're talking about the information we're putting into our machine. The output of a function is the dependent variable, and up until this point we thought of the output as our y value. So this is going to be what I get out of my function machine. And the value of the dependent variable depends on, that's why they call it dependent, depends on or is a function of the value of the independent variable. When I apply the function notation, what I'm talking about is writing y equals the function of, or f of x, where f names the function. When an equation is in two variables describes a function, you can use the function notation to write it. So typically when we write an equation, we use y is our output and x is our input. So when we're looking at the dependent variable is a function of the independent variable, we're saying y is a function of x, and we write it this way, y equals f of x. We're going to write an equation in the function notation for the following scenario. Amanda babysits and charges $5 per hour. So the dependent variable, or the time worked in number of hours, so the number of hours, oops, that's our x. So the amount earned is five times the time worked. And that's being done in hours. An algebraic expression that describes the function rule. We're going to write the equation using two variables to show the relationship. So my output is my time worked, and the amount earned, and the time worked is going to be my independent. So amount earned is my y. It's $5 times the number of hours worked, and that's our x. So there's my algebraic expression. Now I'm going to take that algebraic expression and I'm going to change it to a function notation. So we know that y is the function of x. So the function, which is 5. And we can actually write that. Let me do this. I'm going to change this, the f of x, where 5 times x. Okay. We're going to model using the function notation. We're going to take the information from a scenario, and we're going to identify the independent and dependent variables. From that, we're going to write an equation in function notation for each situation, and then use the equation to solve the problem. So it says a lawyer's fee is $180 per hour for his services. How much does a lawyer charge for 5 hours? So when I'm looking at this, the amount he charges depends on how many hours he works, correct? So my dependent is the fee. So this is my dependent, or my y. And the number of hours, that is my independent. So that's going to be my x. In this case, they want us to use h to represent the number of hours he works. And so that means that if I were to rewrite this, y becomes the function of x, or sorry, h, because they want us to use h, is 180 h. So now we have the function for the lawyer's fee. So the function of the h is 180 h. So the fee is going to be 180 times the number of hours. And they want to know for 5 hours. So we're going to take 180 times 5. That gives us 900. So that means that he's going to charge $900 for 5 hours of work. Let's work on this your turn. For each example, identify the independent and dependent variables. Write an equation in function notation for each situation. Then use the equation to solve the problem. So it says Kate earns $7.50 per hour. How much money will she earn after working 8 hours? So I have to look for my independent variable and my dependent variable. My independent is the number of hours that she's working. The dependent is her money earned. So money earned. So I've got my independent variable and my dependent variable. So this is my function of x. That's my dependent. It's going to cost $7.50 per hour. And I'm going to use x for hours. So now that I have my function notation, they want to know for 8 hours. So this is what we're going to use for x. So we're going to have the f of 8 equals $7.50 times 8. And when I take and put that in my calculator, I get 60. So for working 8 hours, she's going to get paid $60. Okay? If you think of it as the algebraic equation, and then just replace y with a function of your variable, your independent variable, that's how you write these. Okay? We can choose a reasonable domain and range. When a function describes a real-world situation, every real number is not always a reasonable choice for the domain and range. For example, a number representing the length of an object cannot be a negative, and only whole numbers can represent a number of people. You'll never see halves or negative numbers for the number of people. So we're going to write a function in a function notation for each situation, and then we're going to find a reasonable domain and range for each function. So on example A, Manuel has already sold $20 worth of tickets to the school play. He has 4 tickets left to sell at $2.50 per ticket. Write a function for the total amount collected from the ticket sales. So we're talking about the amount that he's collected from the ticket sales. That's our unknown. We don't know what it is. So that is going to be, looks like they're using t. So we have our f of t equals, he's selling the remaining tickets for $2.50. So $2.50 times t for tickets. And he already had $20 worth sold. So he's already sold 20 tickets. Okay? So he has only 4 tickets left to sell, so a reasonable domain is 0, 1, 2, 3, and 4. So if he only has 4, it can't be more than 4, can it? Is a possibility he cannot sell any? Yes. So that's why the reasonable domain is 0, 1, 2, 3, and 4. We can substitute these values into the function rule of $2.50 t plus 20 to find the range values. And so if it's 0, if I have 0, I am going to have just $20. So there's my 20. If I have times 1 ticket, I'm going to have $22.50. And so that's this one. If I had 2 tickets, that's $5 plus 20 is $25, or it's 25, and so forth. So our domain is very much in charge of what our range is going to be. And so it's super important that we're thinking what is reasonable when we're talking about our domains. Let's look at our next example. It says a telephone company charges 25 cents per minute for the first 5 minutes of a call, plus a 45-cent connection fee per call. Write a function for the total cost in dollars of making a call. We're going to let M represent the number of minutes that are being used. So the total cost for one call. So we have the function of the number of minutes that we're going to be using. So the total cost for one call is 25 cents per minute. So that's telling me that it's 25 hundredths times M plus my fee of 45 cents for that call. So the charges only occur if a call is made. So a reasonable domain is, it's possible that he doesn't call anyone, and so it's 0. Or he talks for 1 minute, or 2, or 3. And most cases, it doesn't go beyond, you can't go to infinity because it's too big. Because of that, we want to use what's called a reasonable number. And in most cases, people are at least on the phone for, up to 5 minutes. So we're going to make this our reasonable domain. And then we're going to substitute these values into our function, which was 25 cents per minute plus the 45-cent fee. So when I'm looking at my range, if M is 0, then it's just 45 cents. And if my number of minutes is 1, then we have the 45 plus the 25 cents, and that's going to give me 70 cents. And if it is 2 minutes, I'm going to take my 50 cents plus my 45, and that's going to give me 95 cents. And if I do, see, that's 0, 1, 2, so 3 minutes, so that's 75 cents plus my 45 cents. And that's going to give me $1.20. And at 4 minutes, I have $1. $1 plus the 45 is $1.45. And at my 5, I have $1.25 plus my 45 cents, and that gives me $1.70. So that is my range using my reasonable domain. Okay? I'm going to write each function in a function notation for each situation, then find the reasonable domain and range for each function. So on number 5, it says the temperature early in the morning is 17 degrees Celsius. The temperature increases by 2 degrees Celsius for every hour for the next 5 hours. Write a function for the temperature in degrees Celsius. So the first thing we want to do is to come up with our function notation. So once you go ahead and work on that. Okay, you should have gotten the function of h, where h is the number of hours, when 2 degrees times each hour, plus 17 degrees where it started. So that's our initial. Okay. Now we need to find our reasonable domain. So the reasonable domain and then once we find that, we want to find our range. So go ahead and work on your reasonable domain. So our reasonable domain should be 0, 1, 2, 3, 4, and 5 because it's asking for the next 5 hours. That's why we don't need to go beyond that. However, if no time passes, we also need 0. So that's why that's also included. Now that we've found our reasonable domain, now let's find our range. And you should have gotten the following range of 17 degrees, 19 degrees, 21 degrees, 23 degrees, 25 degrees, and 27 degrees, all in Celsius. If we look at the Your Turn number 6, Takumi earns $8.50 per hour proofreading advertisements in a local newspaper. He works no more than 5 hours a day. Write the function for his earnings. So again, we're going to write the function notation, then we're going to find the reasonable domain and the range for each function. And you should have come up with the following range. If you have any questions about these, please make sure you see your teacher.